So if you recall from our order of operations, first level of priority, highest priority is enclosing symbols. And this fraction bar is a form of an enclosing symbol. So we have to do what's on top first, then we have to do what's on bottom, and then we do the division. So let's do that top piece first. I'm going to move it over here so we have room to work on it. So up there, what is the first thing we need to do? Square, 9 squared, which is 81, perfect. What comes next? 3 times 5, which is 15, perfect. And finally, which gives us, perfect. So 81 minus 15 is 66. That is the top reduced to a single number. Now on bottom, what do we have to do first? 4 times 7 is 28. Next would be 15 divided by 3, which is 5. And finally, perfect, 28 plus 5 is 33. So the bottom reduces to 33. So now that we've reduced both the top and bottom to a single number, we divide out, and of course 66 divided by 33 is 2. Perfect. There's Mauston. We just did this first example of order of operations for you. Okay, so next we have, I'm going to have you try this one in your notes. Give that one a shot. We'll go over that in about a minute. I see some of you are still working on it, but that's fine. We'll go ahead and do it, and you can follow along as far as you made it here. So we have enclosing symbols. Our first one is this parentheses right here. Remember, we move left to right. We find its other end, which is over there. However, inside there, order of operations still applies, and we have another enclosing symbol, another parentheses. So we zero into that. Now, I had told you there were some ways that we can shorten this up so we don't have to rewrite it. I'm going to show you one of them right now. Since we're concentrating inside this brown box, inside that inner parentheses, I'm just going to rewrite what's there instead of rewriting the whole problem. So what's the first thing we do inside that parentheses? 2 times 3, which is 6. So I'm going to rewrite the rest of what's inside the parentheses. So now it's 9 minus 6, which will give us 3. So now what's in that parentheses is down to a single number. I don't need the parentheses anymore. So I can take those parentheses out. So I'm going to rewrite the rest of the problem without those parentheses in there. What do I have to remember to put in here after the 2? Multiplication. That 2 beside the parentheses was implying multiplication. With the parentheses gone, I have to write it in. So now we'll rewrite the rest of the problem, and we're moving out to that outer set of parentheses, or the green box. What do we have to do first there? Two times 3, which gives us 6 again. And now again, I'm only going to rewrite what was inside that parentheses. I took out the 2 times 3 and replaced it with 6, and then I rewrote everything else. What is the next thing I have to do there? 13 minus 6, which is 7. And then, of course, plus 1 gives us 8. So again, I've reduced that parentheses to a single number. I can take them out. So I have 8 plus 7, of course. I have to put in that multiplication. Then minus 2 times 4. So now I'm out to the larger problem, no more enclosing symbols. What do I have to do next? Seven times 8, good, which is 56. There we go. And then 2 times 4 is 8. So now we're down to only addition and subtraction. We're going to go left to right. 8 plus 56, of course, is 64. And 64 minus 8 takes us back to 56. How many of you had 56 for that one? Okay. Now I'll put it out there. There's a problem very similar to this that goes on the test next week. And the most common mistake, and I've mentioned this before, and the most common mistake that is made is right up front here. Oh, 8 plus 7, that's 15. Remember, every number, unless it's the first number or the last number, the 8 and the 4 only have one operation operating on them. But every other number in these problems has two operations. The 7 has the addition in front of it, and behind it is multiplication. That multiplication has a higher priority. So when it comes to that 7, we cannot do this addition until we have done that multiplication. So do not fall into that trap. That 8 plus 7 is one of the last things that we do. In fact, it's not even 8 plus 7. It's 8 plus that 7 times the amount from the parentheses. So that 8 plus is one of the last things we can do. Don't let it be your first. Okay, so then moving on today, we're going to move into what I view as one of the most important topics in math. In my mind, probably the most powerful topic in math is ratio and proportion. Now, that's not what we're going to cover today. It's actually we're going to cover a small piece of ratio and proportion. But ratio and proportion describes basically your variance, your variation between variables. In engineering, I used it quite a bit as far as undefined relationships where I didn't have a formula, but I knew it was a direct relationship or an inverse relationship. I could use that ratio and proportion to find a result even without having a formula. All of your trig is about ratios and proportions. It's known ratios, and we're using that trig value in a proportion to find a missing part of a triangle or of a figure. Actually, trig, if you get deep into it, is from a circle, not from a triangle. Ratio and proportion also applies to what we're covering today, which is probably the most common application that we see out there in the world, and that is percents. We're going to cover percents actually a couple of times in this course. We'll cover it today, and then we'll cover it again at some point in Unit 2 when we go over ratio and proportion in general. We'll put percents in there a little bit just because there's so many applications of percents that I think it's important, especially at your age, at a young age, to see. Then we'll talk about some of those applications when we hit them in Unit 2. Today we're going to cover the basics. To understand percents, you first have to understand the word percent. It's actually two words, per and cent. So breaking it down, if you think of miles per hour or miles per gallon, dollars per hour, per means for each or out of. Cent, if you think of cents in a dollar or years in a century, it's 100. So percent means out of 100. So if we look at something like 38%, that literally means 38 out of 100. In fact, it's that simple to change a percent into a fraction. Now, of course, we wouldn't leave it as 38 over 100 because that can be reduced. 38 and 100 can both be divided by 2. So we'd write it as 19 out of 50. So 38% is 19/50ths as a fraction. Now, those simple percents, I trust that you guys can convert. You know, simple things like 65%. I trust that you can handle. That's going to become 65 over 100. And both of those can be reduced by 5, divided by 5, giving us 13/20. So we're not going to spend time converting problems like that. But we are going to spend time converting something like this. 81.25%, turning that into a fraction. Now I'm going to do an example here and then I'll let you guys try one. 81.25%. Remember, a percent is always out of 100. So the decimal doesn't change that. However, once we get it in this form, we don't like having decimals within our fractions, so we have to do something about that. Now, there are a couple of different ways you could go about it. Some of you might recognize 0.25 as 1/4. You could just multiply by 4 to get rid of that. Multiply by 4 on top and bottom. But there's a simpler, I won't necessarily say simpler, a more prescribed way of doing it. You just look at the number of decimal places. There are 2 decimal places there that we need to get rid of. If I multiply by 100, it moves a decimal point over 2 spots. So if I multiply by 100 on top and bottom, I get 8,125 over 100 times 100 is 10,000. The disadvantage to this is now we have a very ugly fraction to reduce. What can both of those be divided by? Be brave. If you look at the last digits, what does it tell us? They can be divided by 5. Perfect. So there's a start. So we've got 1,625 over 2,000. They can still both be divided by, pardon me? 5. Perfect. So we've got 325 over 400. Looking at it now, they can both be divided by 5, but you might see that they can both be divided by 25, which is going to give us 13 over 16. So 81.25% is 13 out of 16, or 13/16. We should be careful because technically, even though it's in a fraction form, it is still a ratio. It's not really 13/16. It is 13 out of 16. I had mentioned that if we had noticed at the beginning here that 0.25 was 1/4, we could have multiplied by 4 to get rid of it. 100 times 4 is 400. 81.25 times 4 is 325. Notice that skips us ahead a couple of steps in the reduction. And it will still, of course, reduce to 13/16. So if you notice that you can multiply by the 4 and get rid of the decimals, that does definitely shorten it. If you don't see that, however, you can always just go by the number of decimal places. 2 decimal places, you multiply by 100. So in your notes, I want you to try 62.5%, convert that into a fraction, and we'll go over it in about 30 seconds. Oops. So now that we've got it 625 over 1,000, you might see that both of those can divide by 5, or you might find that they can divide by 25, which will give us 25 over 40. And again, they can both divide by 5 to get 5/8. How many of you had 5/8? Any questions on converting a percent to a fraction? Okay. The last example I want to show you looks like this. 36 2/3%. To turn that into a fraction, it is still 36 2/3 over 100. Now, just like we don't like having decimals within our fractions, we don't like having fractions within our fractions. So I need to get rid of that fraction. There are a few ways we can approach it. I'm going to go through what I think are the two easiest ways. One of them is you look at that denominator in our fraction in the top number. It's a denominator of 3. It's 2/3. So I can get rid of that by multiplying by 3. So on bottom here, I have 100 times 3, which is 300. On top, 36 2/3 times 3. Well, 36 times 3 is 108. Plus 2 is 110 over 3 times 3 over 1. The 3's cross cancel. So I get 110 over 1, or just 110. And now we can reduce that. Both of those numbers divide by 10 to give us 11 over 30. The alternative, when we look at that, is just to treat it as a fraction division. 36 2/3 divided by 100. Remember we said fractions and division are kind of interchangeable. When we divide this out, it'll still be a fraction. So we're going to treat that as 100 over 1 so that we can divide it. 36 2/3, again, 36 times 3 is 108, plus 2 is 110, so that's 110/3. Instead of dividing by 1 over 100, we multiply by the reciprocal. So we multiply by 1 over 110. And of course, we can cross cancel. Both 110 and 100 divide by 10, giving me 11 and 10. 11 times 1 is 11. 3 times 10 is 30. So 36 2/3 is the same as 11 out of 30. In your notes, I want you to try 18 1/3%. Convert that into a fraction. So that becomes 18 1/3. I'm going to move it down a notch here. That becomes 18 1/3 over 100. What'd you do with it from there? Perfect. So you divided it out. You turned it into multiplying by the reciprocal. Perfect. So you can either multiply it out and reduce, or you can cross cancel. Both 55, multiplied it out and reduced. Perfect. We can do that. So 55 times 1 is 55. 3 times 100 is 300. From there, what do you need to do? Perfect. We divide by 5 and you get 11 out of 60. If you think about it, it makes sense. 18 1/3 is half of 36 2/3. If 36 2/3 is 11 out of 30, 18 1/3 is 11 out of 60. That is also where your ratio and proportion can come into it. If you wanted to, you could have done that as a ratio. 18 1/3 to 36 2/3 equals x over 11 30ths, you could actually cross multiply and divide to get that missing value. Let's look at converting those percents into a decimal, which is a lot easier. Back to our 38%. We said that meant 38 over 100. Now, rather than reducing that, we're going to go from fraction to decimal. Well, to go from a fraction to a decimal, you simply divide. So numerator divided by denominator. So 38 divided by 100 is easy to do. Since we have a denominator of 100, we'll take advantage of it. When we divide by 100, all it does to our number is move the decimal point. So we think of this as 38 divided by 100. The decimal point on the 38 is right there. We move it over 2 spots. Multiplying by 100 moves the decimal point to the right 2 spots. Dividing moves it to the left 2 spots. So 38 divided by 100 is just 0.38. Every time we convert a percent to a decimal, it's going to be dividing by 100. It could be 52.3%. That's going to end up being 52.3 out of 100, which means 52.3 divided by 100. And when we divide by 100, it just moves that decimal point over 2 spots. So 0.523. So anytime we need to change a percent into a decimal, it is simply going to be dividing by 100 or moving the decimal point. So you guys help me out. 80% as a decimal is going to become what? 0.8. Good. 142% as a decimal is going to become 1.42. 37.5% as a decimal will become 0.375. 8.4% as a decimal will become 0.084. 230% will become 2.3. 0.6% will become 0.006. Here's the one I usually catch people on. 1/4% as a decimal becomes, careful, or at 0.25, that'd still be a percent. That's just moving it from a fractional percent to a decimal percent. Now to make it a decimal would be perfect, 0.0025. One thing that I use a lot, especially in percents, but in other calculations, we talked about rounding before we punch into the calculator for our main operations. Similar to that is something called benchmarks. Benchmarks just mean things that you know and are easy to calculate. One such benchmark is 1%. We know that 1% as a decimal is 0.01. Is 1/4% larger or smaller than 1%? Smaller, right? Obviously smaller. So when we make it a decimal, the decimal has to be smaller than 0.01. So things to keep in your mind as you're doing things are those benchmarks. And we'll talk more about benchmarks as time goes on. We might have things like 0.42 as a decimal, and we want to convert to a percent. Well, a decimal is what's actually referred to as a rate. And rates are typically in what we call unit rates. What a unit rate means is it is out of 1. So that 0.42 is really 0.42 out of 1. So if I want to change that into a percent, I have to make it out of 100. Now it's pretty simple. All I have to do is look at my rules of fractions. If I need to change that denominator from a 1 to a 100, I simply multiply by 100. 0.42 times 100 is 42. So 42 out of 100, or 42%. So you can see here, similar to when we converted percents to decimals, we're just going the other way, doing decimals to percents. Instead of dividing by 100, we're multiplying by 100. So 0.17 as a decimal becomes what as a percent? 17%. Perfect. 0.8 as a decimal becomes 80%. 3.2 as a decimal becomes 320%. 0.063 as a decimal becomes 6.3%. There we go. 0.008 as a decimal becomes 0.8%. Perfect. Last step in our converting is to go from a fraction back into a percent. Anybody have any questions on the decimals? Okay. So last step in the converting is going from the fraction to a percent. Let's start with one that we all know. Of course, we know that 3/4 is what as a percent? 75%. If we didn't know that, we could have done a lot of different things. One of them would have been turn it into a decimal. 3/4, 3 divided by 4, of course, 0.75. Then we could move that decimal point to make it a percent. The other thing we could have done, 3/4, we can think that's 3 out of 4. We need to change it into out of 100 to be a percent. 4 times 25 makes 100. 3 times 25 makes 75. So it's 75 out of 100, or 75%. Not all of our fractions convert that easily, though. If I have something like 5/8 and I want to turn it into a percent, trying to figure out what 8 multiplies by to make a percent is not as simple. What we'd end up doing is take 100 divided by 8 to figure out what that factor is. We get 12.5. So 8 times 12.5 makes 100. So we do 5 times 12.5 gives us 62.5. So 62.5 out of 100, or 62.5%. From this form, 5/8 equals blank over 100, there are a couple of different shortcuts that have been developed for solving it. The first one I'm going to show you, if we just put in that variable there for x, is just from solving an equation. If I want to solve an equation, I'm going to get rid of my fractions, my denominators. The least common denominator for 8 and 100 is, well, probably get away with 200. If I multiply by 200 through the whole equation, (200 times 5/8 ends up being, was that 75? No, 125. And 200 times x over 100 ends up being 2x. And I could solve by dividing by 2. That's a little tricky to do. A simpler way of handling that is simply, we're going to just multiply by the product, 8 times 100, which is 800. And if I multiply by 800, 800 times 5/8 is 500. 800 times x over 100 is just 8x. And you'll notice what we get there. This first number is just the 5 times 100. This second number on the other side of the equation is here, 8 times x. Those are what we call cross products. This is why I called it cross canceling instead of cross multiplying when we were reducing fractions, because this process here is also cross multiplying. Those cross products in a proportion, whenever there's two fractions that are equal to each other, those diagonal products or cross products have to be equal to each other. So then we can solve this by dividing by 8. That gives us the 62.5 equals x. Well, because every time we do that process, we're going to solve that equation by dividing by 8, we can shorten it up and simply do cross multiply and divide. So this is our missing number here. We have two numbers that are on a diagonal with each other, the 5 and the 100, so we multiply those. 5 times 100 equals 500. And then the number that is diagonal with our missing number, or with our x, is the 8. We divide by the 8, and that's 62.5. That process of cross multiply and divide, or over here cross multiplying, excuse me, cross multiplying to get an equation and solving that equation, is used in hundreds of applications in math, all the way up to trigonometry. So if I have something like 2/7 and I want to convert that into a percent, I can make it 2/7 equals x over 100, and I'm just going to cross multiply and divide. 2 times 100 is 200, then we divide by the 7, which ends up giving us 28.57143 approximately. So round that to 28.8%, or 0.6%, sorry. So a little bit of the basic calculations with percent. Like I said, we'll cover this more in Unit 2 when we do our ratio and proportion. But I just want to talk about the basic benchmarks that I mentioned before. Basic benchmarks actually work easiest when you work with rather large numbers. So let's put up something like 4,100. Of course, that represents the whole thing, or 100%. 100% is always the full amount, often referred to as the whole amount or the whole period. Well, 10% is 10 out of 100, or 1/10. So to get 10%, we either move the decimal point over a spot or drop the 0. In this case, it's drop the 0, same, it works out the same. So we get that 10% of that is 410. So if we're trying to find a percent that's close to 10%, maybe 9% or 11%, we can estimate that it has to be close to 410. The next one that I usually use is 1%. That's 1 out of 100, or 1/100th of the number. Well, again, that's dividing by 100, which would be moving the decimal over 2 spots, or in this case, dropping 2 zeros. That would be 41. So let's say I want to use this to find 21% of 4,100. Well, that 21% can be broken down into 10% plus 10% plus 1%. 10% is 410. So at 410 and 410, and 1% is 41. And that adds up to 861. So it's a very quick way, without having to do much calculation, to use these benchmarks to find 21%. Or we might be asked to find 9%. Let's say we're asked to find 9%. I'm going to use a different number now. Let's say we're asked to find 9% of 5,800. So 9%, I'm going to view that as 10% minus 1%. So 10% of that is 580. 1% is 58. I subtract, that's going to be 522 is 9%. As I said, we'll cover percents more in the next unit. For right now, we have a couple pages of homework. We have page 23, 1 through 21, the odd. That's a review of that order of operations. Page 36 through 37, 1 through, I don't have the numbers in front of me. Do odds and just do the converting fractions to decimals to percents on that page. That's all that's going to be on test 1. So as I mentioned at the beginning from Austin, it wasn't in here quite yet. Next Wednesday will be our test 1. On Monday, we have one more topic to cover. That topic is Roman numerals. So we'll cover those Roman numerals and then maybe do a little bit of review for the test if we have some time. But test 1 will be in class on Wednesday. The tests, you are allowed up to 2 hours. And for test 1, on the first 2 pages, and I'll give you the instructions more next Wednesday, you must show your work. So on the calculations, you have to show the steps. You can use the calculator, but you have to show the steps of how you would have gone through it by hand. Okay, I've gone actually 40 seconds over, so I apologize. You guys have a great weekend. We'll see you all on Monday. Thank you.